Welcome to another video lecture brought to you by FilSciHub Ed. And today we are going to talk about one-dimensional kinematics. The main purpose of this learning guide is to provide clear definitions and illustrations of the terms used in physics to describe motion, speed, velocity, and accelerations, which are crucial concepts for the analysis of motion in the later chapter. Hi there, my name is Ivy and I am part of FilSciHub Ed, who helps create modules for chemistry and physics teachers and students. So this is the content standard for this topic. So the learner should demonstrate the understanding of motion in one dimension, and the most essential learning competencies are to describe the motion of an object in terms of a distance or displacement, speed or velocity, and acceleration. Next is to create and interpret visual representation of the motion of objects, such as tape charts and motion graphs. Since driving or riding in a cars is a common activity in our daily lives, we are familiar with the concept of speed. Most of us have had experience in reading a speedometer, and if you describe how fast something is moving, as we did in our introduction, you are talking about speed. Driving along a straight highway is an example of one-dimensional motion. So as you can see here, these cars are experiencing one-dimensional motion because the car can only move back and forth along the line. Math that measures the four main conditions of the car movement, which is time, position, velocity, and accelerations, are very important in understanding the concept of speed. Now, let's go to position. So position, when we say position, this is very important because it lets you know where you are or where you were. And sometimes it can also become negative. So the position on a place or an object is the location of that place or object. So you might describe the position of this city based on the location of another city, or a location to which you compare other location is called a reference point. So for example, the first car in reference to the second car has a distance of, example, it's 2 meters, something like that. So that is what we call position. So you have here a reference point to locate the object or the place where the object is located. Next, let's go to displacement. So when we say displacement, this is the change in position. And the word displacement implies that an object has moved or has been displaced. So from this location or from this position, as we can see, the car moved at this location. Okay, so the displacement is the change in the position. So let us take note that when we say displacement, this is the change in position of an object where the change in position, so we write it as delta x, is equal to the final position minus the initial position. So the final position, for example, of this car is 9 meters. And the initial position was 2 meters. So we can say the displacement of the car, the red car, is equal to 7 meters. All right. So now, what's the difference between the displacement and the distance? So when we say distance, this is defined to be the magnitude or size of displacement between two positions. So the distance traveled is the total length of the path traveled between two positions. So the distance has no direction and thus no sign. So again, what if we have here the location of your first, the magnitude of the first location, which is 2 meters, and it travels along the line up to 9 meters. So we can say that the distance is just the summation of the distance traveled or the total length of your car. So the final position plus the initial position. So we can say that this is just equal to 11 meters. So that's the difference between displacement and distance. Okay, so let us have a sample problem. So solve for the following path. Solve for the following path, which is path A and path C. So we have to know the distance traveled, the magnitude of the displacement from start to finish, and the displacement from start to finish. So now let us know first, what is the distance traveled? Okay, so let us try first the path A. So as you can see here, this is the path A, and the arrow is in the middle of 6 and 8. So we can say that the distance it travels is 7 meters. How about for the path C? So it started with 2, going to 10, and going to the left, giving us 2 meters, and going again to the right, giving us another meter. Okay, so we can say that path C has traveled, so 2, 4, 6, 8, and then it goes again to the left plus 2, and another one to the right plus. Okay, so we can say that the distance traveled by C is 13 meters. Okay, so now, what is the magnitude of the displacement? So we're talking about displacement here. So we can say that the displacement of your path A is equal to the final, which is 7 meters, minus the initial, which is 0 meters, which will give us 7 meters. For path C. For path C, as you can see here, so it reached, so the final position is at 11 meters, and the initial is 2 meters. So we can say that the magnitude of displacement is 9 meters. So now, what is the displacement from start to finish? So the displacement from start to finish is just the same with the magnitude, but we must know that when we're talking about displacement, we must check for the sign. So meaning you have to take note of the positive sign and the negative sign. So here, on the first given, which is the path A, since your final velocity or your final distance is positive, means that the displacement is just the same with the magnitude. How about here? So it goes to the right and then goes to the left and again to the right. So as we can see here, it is just the same with the magnitude. And since we can say that the displacement is positive because you have a positive final distance minus the initial distance or the initial location. So that's why you will have a positive displacement from start to finish. Okay. So these are the final answer for this sample problem. So now let us go to the average and instantaneous speed. So what's the difference between the average and instantaneous speed? So when we say instantaneous speed, it is the rate at which the distance is being covered at a given instant in time, while the average speed equals to the distance traveled divided by the time of travel. So in this figure, the instantaneous speed of your car at this point is dependent on the time traveled or the speed of your car at that instant time. How about for the average speed? So for the average speed, we must know the total distance it traveled and we must divide it to the time that it traveled to that distance. So this is the formula for our average speed. So the average speed is equal to the distance traveled divided by the time of travel. So we can say that the average speed is equal to the total distance or the total length it traveled over the time elapsed. So we can represent this using symbol S for speed equal to D, so the distance over time. Okay, so the unit of measure that the SI unit that we can use here is meter per second. It can also be kilometer per hour or vice versa. So now, what's the difference between speed and velocity? So when we say velocity, it involves the direction of motion as well as how fast the object is going. For example, you have here two cars that are moving. And the first car, it has a certain velocity. And since it is going to a different direction, right? So medyo nag-curve yung ating car. So it means that it need to decrease its speed for it to follow po yung curve line, right? Okay, so again, velocity, when we say velocity, it is it involves the direction of motion as well as how fast your car is moving. So we can say that the velocity, the first velocity is different from the second velocity. So the speed, as we all know, it only defined as how fast an object is moving, but does not say anything about the direction of your motion. So that's the difference between the speed and velocity. Okay, so average and instantaneous velocity. So what are the difference between these two? So the quantity that tells us how fast an object is moving anywhere along its path is the instantaneous velocity, while the average velocity is the displacement or the change in position divided by the time travel. So please take note that the instantaneous velocity and instantaneous speed are closely related, but velocity includes direction as well as times. So this is our definition for the average velocity. So average velocity, this is the displacement or the change in position divided by the time traveled. So average velocity equal to the change in position or displacement. So we define displacement as the change in position. So you have your final position and initial position divided by the time of your final and beginning position. So time 2 minus time 1. Or we can say that this is the difference on the position and difference on time. So this is our formula in getting the average velocity. So now let's have this as an example. So a man walks 7 kilometers in 2 hours and 2 kilometers in 1 hour in the same direction. So what is the man's average speed for the whole journey? How about the average velocity for the whole journey? So as you can see here, I provided an illustration where you can see the distance traveled by the man. So 7 kilometers in 2 hours and 2 kilometers in 1 hour. Now, how do we determine the average speed? Again, we just have to know the total distance the man traveled. So yung total distance niya po is just adding the magnitude, so 7 and 2 kilometers over time. So the total time na travel niya po yung distance na yon. So that's why you have 2 plus 1. Okay, so for the speed, you will have 3 kilometers per hour. How about for the average velocity? So for the average velocity, it means that we must know the difference in the position of your object or yung position po ng man. So since dito po, given sa atin na nag-start siya from 0, so for example, nag-start siya from 0 and na-attain niya yung 7 kilometers. So 7 po ito and then another 2 kilometers. So this is 9. So we can say that the change in the position is 9 kilometers. It's because your final position is 9 kilometers and the initial position is 0 kilometer. Okay, and then we're going to divide it dun sa time na na-elapse niya. So we will have 2 plus 1, or we can say that this is 3 hours and this is 0 hour. So that's why you will have 3 kilometers per hour. How about when you have a different direction? So what if a man walks 7 kilometers east in 2 hours and then 2.5 kilometers west in 1 hour? So ito po yung illustration natin. So nag-walk yung man ng 7 kilometers papuntang east and 2.5 kilometers papuntang west. So again, for the average speed, we must know the total distance. So we're just going to add yung magnitude po natin, which is 7 kilometers plus 2.5 kilometers. And then we're going to divide it to the total time. So for the man to walk 7 kilometers, nag-take siya ng 2 hours. And para naman po doon sa 2.5 kilometers is an hour. So that's why 2 hours plus 1 hour, which is 3. So you're going to divide your distance to 3, which will give us 3.2 kilometers per hour. How about the average velocity? So again, when we're talking about velocity, this is the displacement. Okay, so makikita po natin that the final position is here. And the initial position is here po. Okay, so what are we going to do? So since yung initial position po natin, which is 0, and how do we determine the final? So we must subtract 7 kilometers to 2.5. So that's why you will have 5.5. So your final position is 5.5. And you're going to divide it to, 4.5 po pala. It should be 4.5 kilometers. And then you're going to divide it to how many are para matake ni man makapag-walk ng 4.5 kilometers. That's why it will give us 1.5 kilometers per hour. So take note that there is a difference in the average velocity when you have a different direction. So as you can see here po, so dito, the same lang po yung nakuha natin for the speed and velocity because they have the same direction, while here, there's a difference between the speed and velocity because of the change in direction. Okay, so now let us know what is the difference between the constant velocity and the changing velocity in terms of graph. So this is an example. As we can see here, this is the position of our car at a specific time. So we can say that at position 10 meter, which is na-cover niya po in 1 second. So yung velocity nito is 10 meters per second. So when we plot it on our graph, you will have this one. How about this one po? So 20 meter over 2 seconds. So this will give us velocity of, again, 10 meters. So mapapansin natin that they have a constant velocity. So kapag constant po yung velocity natin, wala po tayong slope na mabubuo. So you just have a constant line or a line lang po. How about this one? So what if there is a change in velocity? So this is the given position and the time it took for it para ma-reach tong position na to. And as we can see here, there is a change in velocity. So when we have a change in velocity, we expect that there will be a slope. While when we have a constant velocity, so constant lang po yung speed. So ibig sabihin, wala tayong ma-form na slope. All right. So what is the difference between the positive velocity versus the negative velocity? So again, kasi sabi po natin na when we have a positive velocity, it means that your object is moving on the positive direction. And while when we have a negative velocity, so ito po yung negative velocity natin as you can see, so it is traveling on the negative direction. How about for speeding up and slowing down? So if the line is getting further away from the x-axis, it means that is speeding up. So ibig sabihin po kapag meron tayong slope na pataas, sasabi natin na yung object natin ay nag-speed up. How about this one? So if the line is approaching, so it is approaching the x-axis, it means that yung object po natin is nag-slow down. So that's the difference between speeding up and slowing down in terms of graph. Our acceleration is equal to the change in velocity over time. So let's have this as an example. Calculate the acceleration of Josh riding his bicycle in a straight line that speed up from 4 meters per second to 6 meters per second in 5 seconds. So this will be our solution. So the acceleration is equal to the difference on the velocity over time. So yung 6 meters per second po natin, which is the final velocity minus the initial 4 meters per second over 5 second is equal to 0.4 meters per second squared. So ito po yung answer for the next problem. So you can try this at home. Okay, so now what is constant acceleration in terms of graph? So as we can see here po, so this is a velocity time graph. So kapag nag-increase yung velocity, it means that you have a constant acceleration. So again, when there is a change in velocity, it means that you are having a constant acceleration. And kapag constant naman yung speed natin, ibig sabihin, wala pong acceleration na nabubuo. So the steeper the line, the greater the acceleration of an object. Okay, so dito po sa image nito, yung purple is the steeper line and the green one represents that you have there a constant velocity and meron ka ding constant acceleration, so which is ito po, and constant deceleration. So ano naman yung constant deceleration? So yun naman yung pagbaba ng acceleration. So dito naman sa figure na to, we can see that there is a uniform motion, uniform acceleration, sorry, here, and constant velocity, so there's no acceleration. So kahit deceleration, you have uniform acceleration. And again, a constant velocity and a uniform acceleration. So that is the graph for the constant acceleration. So this is a supplementary video that you could Check. So it is a motion in a straight line. So the first episode for crash physics and the is Mara introduces the ideas of motion in a straight line, and she talks about the displacement, acceleration, time, velocity, even the graph po is included in this supplementary video. You can also try the following problems at home po that I provided. And I think that's it for today. Thank you so much for watching. I hope I could see you next time. Bye-bye.